Hi, everyone. Welcome. Thanks for joining today's webinar. We'll probably give it another minute or two before we go ahead and get started. All right, I think we can jump into it. Welcome, everyone. My name is Amelia Henry. I'm an architect and senior partnership lead here at Finch. I'm joined today by Jesper Wahlgren and Philip SK. They'll introduce themselves here in a second. But the idea with today's webinar is we're going to walk through a workflow of how to start from an empty project and generate through it, and then finally bring it out into Revit. Jesper will also go a bit through Nano, our new integration, and how we're working with that image generation and extracting vectors and this sort of thing. I'll hand it over to Jesper for a quick introduction of himself as well as Philip.
Very nice. Hey everyone, my name is Jesper. I'm an architect by training, and here at Finch, I'm one of the founders, and I'm in charge of the product. So just as Amelia mentioned, I will say a couple of words about and do a little demo of Nano. That's our latest integration. Also talk a couple of words about what we're up to during 2026 and the roadmap there.
Yeah, and I'm Philip. I'm an architect here at Finch, mainly working with the creation of the data sets for the clients.
Great. And as we go through, feel free to ask any questions in the Q&A. We will go through them at the end. And of course, the session is recorded and we will send it out to everyone in the coming days. With that, I'll go ahead and share my screen and we'll jump right into it. All right, so just a bit of background about Finch. Finch is a generative copilot aimed at architects. As you can see, all three of us here on the call have a background in architecture, and this is really who we envision using Finch. It is a design tool at its core. Finch was started back in 2020 by Jesper and Pamela Wahlgren. You may have seen this GIF online, the adaptive plan. It went pretty viral as a lot of people were interested in sort of this new way of looking at architecture, being able to generate different spaces and have an architecture that was reacting to the constraints set on it. This allowed us to kind of build up the first waitlist and secure funding to start building Finch. Here is our architecture team today. Some of us here, Pamela Wahlgren, co-founder, CEO, Jesper Wahlgren, co-founder and CPO. Myself work as senior partnership lead, and Ruben Harris, who you guys might have seen on tutorials or things like that. He's working as our customer success manager. Currently, we have over 100,000 on our waitlist, which is quite exciting, but also we can't open up to everyone all at once. So what we're doing right now is the enterprise partnership. And this is where we partner with select firms. It's a minimum 1 year partnership. And the really crucial aspect of this is that we build a custom data set for each firm. This means that when these firms are generating plans, it's not just random AI generated plans. These are in their local style, up to following local regulations and things like that. And also our architects build this data set in-house. And so this is part of the reason that we have to kind of limit the amount of firms that we are able to partner with. If you're interested in getting access to Finch Enterprise, feel free to reach out to us about this and we can see when we can pitch you guys in. Here we have a case study with Shepherd Robson. This is one of our UK-based firms. They use Finch for early stage feasibility in this particular project. They actually had a feasibility study that they weren't able to quite hit the numbers that was needed to make the project financially viable. But then they gave it another shot with Finch, and not only could they actually solve the project, but they could actually produce 30 iterations, all hitting the targets that they were looking for. So what's really crucial for Tom Kyle, associate partner there, is really being able to produce multiple iterations in that same amount of time. And the bottom line with AI, with Finch, you're going to save time, but how you choose to reallocate that time It's entirely up to you and your business model. In the case of Shepherd Robson, they choose to kind of produce more design options but keep the same amount of hours. But we also do see some of our firms looking to reduce hours, especially when they're working on competitions. This is one of our French firms. They do a lot of competitions. So for them, being able to limit the amount of time per competition means they can submit to more, win more work, and that's also better for their business model. So we can kind of discuss with you what makes sense and how you want to leverage Finch in your workflows to make it beneficial for both you and your clients. In this particular project, this French firm was able to generate 220 apartments in just 3 hours. So 13 times faster than traditional methods. And of course, those plans that are generated, they're, coming out up to Paris codes. They're with their French furniture. So that custom data set is really the foundation of being able to generate quite quickly. We have two different tiers on Finch currently. So we have Finch Basic. This is open to everyone. Anyone can sign up. We have a 14-day free trial. This has limited features. So it includes the floor plate algorithms, all kind of highlight what's included in Basic and what's included in Enterprise here today. Basic is a single user tier, whereas Enterprise includes all AI features. And this is aimed more at teams with a custom data set and these sort of things. So the three sort of main values of Finch, first one is generating plans in your style. So your wall widths, your door widths, everything will look very familiar. Finch is a full editor as well. So you as the architect can always go in and customize, move walls around, change out furniture. You do have full editing control of everything that's generated. By way of building up this data set, we essentially are creating a plan library or an archive of all of your past residential projects stored and hosted up in Finch. And anyone in your firm can access this, go in and kind of see the plans that you guys have created before. And this is a good way also to let junior architects work a bit more independently, as all of these plans contain metadata about regulations, client relationships, these sort of things. Here we have a Nordic Office of Architecture. This is one of our Scandinavian partners. They have a really nice data set, over 300 plans. They actually have offices in both Norway and Iceland, so they have kind of two separate sub data sets within their larger one. And this is something that we strategize with all of our partners about, how to kind of split up the data set. Some clients want different data sets for different cities or states or clients. In this case, it's countries, but we can be really flexible at how that's kind of organized. We bring everything out into Revit. I will go through this here today, but everything's coming out as a native Revit file. We have a plugin that lives inside of Revit. So that means that it's custom families, model groups, area plans, everything's coming out really structured. You have all your data ready to go to create your schedule, so you don't need to redraw anything. We currently support multifamily residential. This includes hotels, student housing, master planning, kind of anything with a bed. With the introduction of our Nano Banana integration, we are expanding the scope of typologies that we do support. So Jesper will go through that a little bit more here today as well. Softwares, Rhino, Revit, Grasshopper, as well as Forma. And this is sort of the workflow of Finch. So you start off in one of those external softwares. You generate or create the mass. Finch does not generate a mass inside of the web app. This is always brought in by the architect. Inside of Finch, you're working through the interior of the building, generating your floor plates, generating your unit plans, working iteratively, presenting to your clients. Once you're kind of ready to move out into the later stages of the project, then of course you can do that export with that native Revit file down into Revit. All right, with that, I'm going to hand it over to Jesper to give you a sneak peek of what's coming with Nano Banana. And then after that, I'll go through the Finch workflow.
Thank you, Amelia. So before we dig into Nano Banana, I would like to say a couple of words regarding what we're building during 2026. And there's mainly three things, and that's Archicad, that's a 3D editor, and offices. And what I mean when I say that is that we're right now, just as Amelia mentioned, we connect to Rhino, Revit, Forma, and Grasshopper. Now we also will connect to Archicad. This will be released the 1st of February, maybe even a couple of days earlier, but then we will make all of our potential Archicad users very happy. So that's the first thing. Then we also have a 3D editor coming out. That will be a little bit before the summer. And what's great about that is, of course, then you will be able to start in Finch. So then we will accommodate the SketchUp users as well. And of course, you will be able to iterate faster on your massing in Finch as well. So Archicad and a 3D editor. And the last thing here is that we're digging into new typologies. And we said that we're starting with offices. That's still the plan. But for some context here for the Nano Banana and offices, I would say a little bit before Christmas, there was a breakthrough in a lot of the big models, especially Nano Banana, I would say, where the big models, in this case from Google, started to understand spatial relationships much better. And that was really interesting, we thought. For now, before this, they were struggling a little bit with it. We at Finch has always been very good at it, but we were a residential only platform. So we started to look into how we can help you leverage the advancements in the technology. And this is what we're going to demo here with Nano Banana, basically. So I'm going to start with sharing my screen. There you go. This is my favorite project. It's 56 and Leonard in New York. I usually demo a lot of things in this, and today we will demo a bunch of things here as well.
Jesper, I don't think we can see your screen.
Oh, sorry about that. Now, does it work?
Yep.
Thank you about that. That makes the demo much more interesting. Okay, so here we have 56 and Leonard in Finch, and as you might be familiar, you have your project, you have your plans, everything is very well structured. If you go into story, we can see all our different spaces within this particular story and so on. So this is of course a residential tower, but if we scroll down a little bit here to a story, I just deleted one of the apartments and I'm going to run Nano Banana here. I choose this particular apartment because it was a little bit more chunky and more suitable for an office. So if I just fire that up, and then I'm going to explain a little bit what happens here. So I'm going to select the unit, click generate, and then we're going to run Nano Banana inside Finch. So you don't need a Nano Banana account and so on. We take care of that. And then I'm going to say, I would like to generate the office for 25 people. Just fire it up here. Let it think a little bit. So, of course, these models has progressed a lot. It becomes much better, but for you as an architect, it might be tricky to take advantage of the leverage the new tech. I mean, it is still a chat in a browser. It has no context of your project. It's pixels that comes out and so on. So what we're doing in Finch for you is basically that we take your unit or your project, we send it into Nano Banana with some context so we know where the walls is and where the stairwell is and all of these kind of things. That can be really tricky. And then we generate a result, or you generate by prompting in Finch. And as you can see, our office is coming in here. And most importantly, it's not just the pixels that comes out from Nano Banana. We translate it to vectors. And that means that you get measurements, you get correct areas. And if we add it to the story here, just give it a second. I'm just going to add it here. It's also editable. So we have the picture I generated in the background. If I turn that off, for example, I can also go in and, move the walls, change the doors, change the direction, add my own furniture and so on. So this enables you as an architect to use the latest tech from Google, OpenAI, and much more within Finch, and you can edit anything. You can use our graph rule to make sure that it follows your regulations and so on. So this is a big thing for us. Now I demoed an office here, but if we jump down a couple of stories, let's see, here's an empty story. I mean, it's not only offices, it's only your imagination that limits it. So we can say generate a gym of 8,000 square feet. There we go. Let's see what happens. Give it a couple of seconds. So this is the benefit, of course, of us using these big models that have been trained of all internet. I mean, we're going from just being experts on residential to now tapping into a lot of new typologies, but still you're able, of course, to use our powerful editing tools and analyze tools and so on in Finch. Here we say that we get a gym out with all of the gym machines and so on. And it's tracing the walls, and it's up to you to continue from here on. I would say that this is it for now. Anything I missed here in the demo, Amelia?
No, I think that's great. Thanks.
Okay.
All right. But so with that, we'll kind of jump into starting a project from scratch and generating. So this is the residential workflow of Finch with the typical generate floor plan features based on the custom data set. And as mentioned, Nano Banana is still a new feature, so we'll be rolling it out here over the next couple of weeks and months. And we're excited to kind of see what you guys can do with it. So I'll go ahead and share my screen again, and now we'll jump into working through an entire project. All right. So here we are inside of Finch. And for those of you who aren't familiar, Finch is a web app. So all of the computation and calculation is happening on our servers up in the web. We have, of course, plugins that's primarily for sending and receiving geometry. We do a little bit of generation in Revit and soon ArchiCAD as well, which I'll go over. But I mean, the bulk of the workflow is happening up here on the web app. Right now, we're looking at a custom data set. So this is Acme Architects, a demo firm. They have 196 plans in their data sets. It's quite a nice big data set. And, you know, I'm an architect here at this firm, so I can come and click around and see how these plans compare to each other. And every time that I click on a plan, I see that, you know, things are changing a little bit over here on the right side. I can see how this plan compares to the rest of the data set in this area versus edges, spaces, access, things like that. You also can, of course, use the diagram here to plot, you know, area versus area. We see that we have a really consistent area spread across this data set, so we'll be able to get a lot of different results. This is just a nice way to get kind of an understanding of what you guys have generated in the past in your projects, and also what you can expect to generate going forward in the future. Over on the left, you have a lot of filters, so you can look at, you know, your programs, circulation, space types, different, you know, you can see, show me all of the plans that have both a storage as well as, here we have some French space types in here. Let's see, like storage as well as a balcony, for example. Looks like we have just a few here, but this is a nice way to kind of isolate plans down. You can also apply the tags, so you could just say, like, show me all the plans that are wheelchair accessible, these types of things. So this really allows all of the plans and projects that you've created in the past to become a kind of indexable data set that you can reference and keep for the future. If we jump into the actual plan itself, let me just click here. Here we see the plan with the graph overlaid, and the Finch graph is the way that it essentially reads architecture. So essentially we place a node in each space, and then we map the relationships between these nodes, which allows you to set up rules about how they can relate to each other. In this case, we don't have any errors going on. Essentially, everything is kind of following all the rules that we've set so far. But if I were to just go ahead and take something like this and drag it down a bit, immediately we're going to get a little error here. If we hover over this node, we get a description of what has gone wrong. In this case, it's that we have an object collision. Essentially, this means that the accessibility rules are not being followed. We have this clear space around this bed, and there's a dresser colliding with it, so it's throwing an error. In this way, I often kind of describe this as a spell check for architecture. It's there, you know, it's going to make sure that you're not having any small errors that you might not notice that are going to cause you headaches later on. You also can kind of preview how Finch might adapt this plan into new scenarios. In this case, if we, you know, make the plan a bit wider, we can see that things don't move proportionally. Of course, this type of stretching is a bit excessive. We probably would never do this in a project, but just to show that things don't move proportionally when we do this. And this is because when we set up the data set, we are going to be adding constraints. So in this case, we've said that this bathroom is a fixed dimension, it's a module, it should never change in size. Same goes with the dimension of the corridor. Bedrooms can get bigger, they can't get smaller. So Finch is using this type of context to be able to reuse and regenerate these plans into entirely new contexts. For every plan that we add, we also try to add as much metadata onto it as possible, because the more metadata you have on a plan, the more control you have while generating with it. Here we see the tags associated with this plan in particular. We see developer A, that's just a sample developer, FHA, New York City, Project A, Type B, USA, wheelchair. These tags can be pretty much anything. And this is the way that we can create these sub data sets. So when you're generating, you could say, okay, actually, I want for this project to show plans that are in the style of this client that we work with that are from New York City that are affordable housing. And you can get the results that are going to follow those typologies. All right. So once we're ready to jump into a project, here we have a double-loaded corridor. This is on a site located in New York. In this case, we have the key figures instantly on the left side showing our GFA, our GIA, all of that. And this building has just come straight from Rhino, straight from Forma, straight from Revit. However you decide to start it, it's going to drop in here and look something like this. The first thing I always do is start to assign out programs. So let's say that we want this to be Resi up top. Let's say that we want it to be restaurant here on the bottom. And Finch is a full editor tool as well. So, I mean, if you know that actually half of this bottom floor is going to be office and I want to generate the office with Nano Banana, I mean, you can come in here, assign this out as office and work through that process. In this case, we do want to just generate on this upper floor for the residential plans, but we can always jump back down into Rhino and we actually have a live connection running here. So if I just turn on my shaded so we see it a bit nicer, we can see that everything is updating in real time. And if I was to go and actually say that, I want this office restaurant floor to actually extend up to the floor above it as well. And maybe I want to add another type of program in here. Let's say that we can add a wall here. And let's make this maybe a pool, for example. We just add that right in there. We jump down into Rhino. Here, let me just move our zoom bar there. And then we see that actually has already updated. So that we've gotten that wall, this has moved up. So everything is updating in real time. And if you do want to adjust the mass, you simply do that, hit sync and send it up. Once we are happy with the mass, we can always check out our areas. So we have more specific, carbon calculations, revenue. We can set up any type of calculation we might wish here in the massing studio and kind of proceed from there. Let's say we're happy with this mass. Now we want to jump down and generate. In this particular project, I want to generate the corridor from scratch, but you can start in a lot of different ways. You could upload a corridor from Revit or Rhino. You could also draw in your corridor up here in Finch. So you don't have to, every workflow doesn't always look the same depending on the project. There might be some projects where you're doing like an adaptive reuse where you can't change the core. So you need to have it preloaded and generate around it. So this just is kind of based on the specifics of the project. In this case, we're generating the corridor. So I'll just fire that up. And right away, we see that Finch actually has already kind of remembered my settings. So it's giving me a great result instantly. We see that we've asked for between 1 and 4 stairwells. I see that my stairwells are facing inwards because I've toggled on my stairwell attractor. When we look at the egress distance for fire rules, we have between a maximum of 8 meters for single exit, which is shown here in green. And then we have a maximum of 20 meters for multiple exits, which are shown here in gray. If I was to update that, let's say we actually want 9 meters on the single exit, it's going to resolve that. And we'll see that actually this green dot is now that 9-meter rule as opposed to that 8-meter rule. We can always add dimensions and customization. So we can input wall width, core depth. Everything here can be customized. And the logic with this is that this algorithm should be able to be used anywhere in the world because the architect is kind of inputting the parameters that this is going to solve for. So it doesn't matter, what side of the world you're on. You can always just input your local dimensions and Finch will kind of solve that puzzle for you. Once we're happy with the core, then I'm going to go ahead and generate the units. And instantly, we're going to get a nice unit mix popping in here. And in the upper left corner, I can see the sizes I requested, 45, 65, 85 square meters at 25, 50, 25 ratio. And what's happening here is similar to an evolutionary solver. Essentially, Finch is proposing two results. It's scoring and evaluating them, taking the one that wins, and then just iterating down on that, 10,000 times. Every time that we see this iteration counter running up, that's kind of Finch taking a decision and continuing down a path. And then, of course, when a new one wins out, that's when we will see it kind of rendering and popping up here as a baked version on the canvas. Every time that Finch takes a decision about the path it wants to go down, it's actually running a scoring algorithm, which you as the architect can influence by telling it what is the most important for this project. In this case, I've told Finch that on this project, I want my size to be really accurate, and I also want to have a good daylight performance. So looking at facade floor area ratio. This means that if we have one option that performs well on those two metrics and another one that's amazing on the unit mix and adjacency, the one that is performing better on the metrics that I have prioritized is still going to win out because that's what's most important for this project. So this is kind of the way that you can iterate with the algorithm and input more of those softer preferences into the design decisions. You can always input harder regulations that Finch kind of needs to follow as well. So in this case, if we kind of expand this, we see that on all of our 45 square meter units, I want at least 4 meters of facade. But then when we would look at our larger units, the 85 square meter, then I want to see at least 8 meters of facade. This can be a really nice way to work with, larger apartments that need larger viewpoints. You also can input minimum dual aspects, grid lines, things like that. If I do toggle on my grid lines, I can snap to them like so. And then we can see that Finch is going to, follow these structural considerations that we've added here. All right, let's let that run again here. But once I have something that's looking good, of course, I can continue to iterate. I can make a lot of different options, play around here quite a bit. But for time's sake, let's just say that this is the iteration that we want to work with. And now I want to go in and start actually populating this with my apartment plans. So I'm just going to jump right in, hit generate, and now we're going to generate floor plan. And right away, we're starting to get some results. So we're getting a few different result sets. So up top, these are my plans. They're private to me. They're ones that I've kind of saved out over time. Down below that, I have my firm's plans. So this is Acme Architects plans. And these are only visible to me and my colleagues. These are in my style of my company. They have my wall widths, my door widths, my furniture. They're going to look very familiar. Here in our demo data set, we have a lot of random plans. I mean, this is more of a Swedish style. Here we have a French style. But of course, these plans will be in the style of what you guys are used to working with. You also will get Finch results. These are available to everyone on Enterprise. And this is unfurnished plans from all around the world. These can be a really good jumping off point, and then you can go ahead and furnish them with your own furniture afterwards. But of course, the fastest workflow will always be to use your own plans, as these have your furniture, they have your regulations, they're ready to go. You also have a graph system kind of working here behind the scenes. In this case, I've set up a little graph system saying my double beds need to be 10 square meters, single bed 7, bath 6, etc. And here in the results, we actually see that we have a 77% result with an error here. And if we hover over that, we see that the area of the bathroom is a little bit too small, so it's highlighting red. And that's also why we see that the score of this plan is dropped quite low because Finch detects an error. We don't by default hide this error because we do believe that it's up to the architect to decide if they want to, continue with this plan. In this case, maybe you just move the wall a couple of centimeters and you would be good to go. Or maybe 25% of the units can have a bathroom that's a little bit smaller. This is entirely up to you, but it's just crucial that you're making an informed decision. If you don't want to see these plans that have errors, you can always filter them out as well. And now you're left with plans that are all going to follow your regulations. You can more look at them from an aesthetic perspective rather than worrying about compliance. Each plan does have a score. So we have 94%, 92%, 91. The score is a combination of a couple of different metrics. We have adaptivity, compliance, and daylight. And then those three together make our total score, which we see here. Adaptivity is basically how much we've had to change the plan from its original sizes. So in this case, we see that we actually have some constraints acting on this plan because the bed, bath, storage, all of this part is 100% of its original size. So that is locked. And then we see that it's the social spaces that are taking that flex, which is exactly what we want to happen. Here we have a plan that is very kind of similar to its original size all across the board. So this one probably doesn't have any constraints acting on it. Compliance, all the plans we've already filtered out the graph, so we don't have any issues. But of course, if we look at that, then we see that we have this bath that is 80% too small. So that's why we're getting that error there. Daylight, the spaces that need daylight have it. So in this data set, we've said that beds, great rooms, and kitchens need daylight. And as we can see, they have access to the facade. So then you're kind of going to be good to go. And here actually we see that we don't have any results that have bad daylight up high as this of course affects the score. So if we have some, they're not going to be shown up top. One thing that I think is always kind of interesting to note is that even though we actually already filtered out our errors here, we still have a plan that is a 66%, and we can always turn our filter higher so we don't see any plans that are this bad. But this is just a really interesting case because technically there's nothing wrong with this plan. It's following regulations, from a perspective of the code, it would be fine to build. But of course, we see that this plan has such a low score because we've had to take the bathroom, the storage, and the hallway and make them so much bigger that you kind of are losing the design context. And so Finch is understanding that even though this plan is compliant, it still is probably not good architecture. But you still, of course, have the option to see it. But Finch is just there to kind of let you know that we probably don't recommend that you use this plan. You can also filter results. So program spaces. So we can say we want one bedroom, one bath, and we can say we want plans from North America. We get a lot of Finch plans here. You can also filter by the specific tag. So here's where you could say you want affordable housing, wheelchair accessible, these types of things. All right. But once we have a plan here that we are happy with, then I'm just going to go ahead and assign it out. Now that's baked. So this is real geometry. I can go ahead and further edit it. Anytime I do edits in Finch, I always turn on my graphs because this is acting like spell check. So if I just go ahead and drop that there, we see a little bit of an error here, object collision. This is no big deal. I mean, this is not going to really cause me any issues. This will import into Revit fine, but it also will just take me 2 seconds to move that down a bit. Now we're good to go. And now I can go ahead and repopulate this plan. So if I just hit Control C, then I look at my unique units and I see that we actually have a nice group here of 8 units because in that previous step, Finch is trying to create as many identical ones as possible. So I'm just going to Control V, drop that in. And now we see that we have a nice linked model group. So this plan's used in 8 units. And any changes I make to one of them will be committed to all of them. So if I go ahead and look at my firm's furniture library, we can drop a cat into the bedroom, and that's committing to all 8 units. And of course, any edits to those will commit to all. If we next just go ahead and Control C, Control V. Now we are going to drop this right through the building and create a really nice model group with, let's see how many units on it, 120 units, all editing simultaneously, super snappy. And of course, that will be brought into Revit as that model group. So it goes really fast to kind of populate through a project. Once you have a completed project, then you can see something like this. So this is a finished high-rise fully generated in Finch. And this is kind of we're at the stage where maybe we're ready to bring it out into Revit. Maybe we're ready to present to our client. We've actually seen some of our clients are presenting exclusively in Finch and kind of delaying that Revit export because you have so much data to work with here. Over on the left, of course, you have your key figures. And then on the right, we have the breakdown of the data. So if I look at my programs, we see our total GFA, office, circulation, carbon. We can also look at our space types. So vertical alignment and stacking of those, unit mix, our size ranges. And then of course, we have our model groups here. So we see that, all of our 2-bed, 3-person type B units are here within the building. This can give us a really nice overview of what we're working with. And the structure of this naming system is actually coming all the way from the data set. So when we build up the data set, we keep it very organized because a lot of these naming systems will follow you all the way down into Revit. So it can be a really nice way to keep everything in your style and up to your naming structures. We also have schedules up here. So we can see all of our different walls, our objects, doors, things like that. And of course, those graphs are acting here as well. If we take a look at a tower with some office, we also have some nice ways to kind of evaluate like egress distance and things like that. This can be a really nice way working with the schedules here. We can just instantly see that, okay, we have 26 desks. So this is a 26-person office. We can also see our measure paths here. So we can see, from our entrance door, what is our fire exit distance to, this office here. We can set in custom offsets. So this is a really good way to just evaluate that we're following our code here, even after we're done generating. All right, but with that, I think we're going to jump down into Revit and take a look at our export and generate a little bit there. So I'm just going to open up Revit. So here we are inside of Revit. And you'll notice that this is that same high-rise project just brought down into Revit. And first thing we'll take a look at is the fact that you have your model groups here. So if we just click on that, we see that we have that naming structure brought all the way in. And then within that model group, we actually do have those custom Finch families. So we have the basic unit wall 120 mil, and these are real doors, real furniture, room tags, everything is brought in here. So you can create schedules really nicely, and you have kind of all this data to work with. We also have our rentable area plans here. So NIA, GFA, all of that's there. When you're actually ready to import a project, if we just click import here, you get this dialog box, and you can actually import your settings here so that you can have, your Finch families being auto mapped to your existing families in your file. So everything will already come in your style, whether it's walls, doors, furniture, slabs, you can have all of that there, and you can actually save profiles so that Finch will just automatically do this every time to make that process really, really smooth. Last thing we're going to go through before we take a look at Q&A and the poll is going to be generating here inside of Revit. So if we go ahead and delete this apartment, now I want to actually generate a plan. So I'm just going to click right inside of this unit, and then I want my door to be placed on this wall, and then I'm going to go ahead and hit finish. And then now we are instantly going to start getting some results from our data sets up in Finch. This is a really good way to introduce the architects to using Finch for the very first time, as you're just going to get plans popping up right here, already in your style, leveraging that data set. And it's essentially 3 clicks. So this is a good way to just kind of surpass that learning curve of getting a new software into your architect's hands. We also see architects using this for late stage changes. If you need to add a wall in and you're pretty heavy into Revit, it can be a nice way to just simply generate really fast and then kind of proceed from there. This feature, as Jesper mentioned, will also be coming into ArchiCAD here at the end of January, so you'll also be able to leverage that in ArchiCAD as well. All right, I'm thinking last thing I'll show is actually bringing out into Revit as well. If we just go ahead and want to bring in a 2D model of kind of our CAD drawings here, let me just import that. We're going to receive some geometry right here into Rhino. All right, there we have it. So look at my top view, see what we have. Zoom in there. And so here we can see that project that I was working on brought down into Rhino. We see that we get a different floor plate, and we're bringing in both surfaces, curves, blocks. So you have a lot of geometry to work with here as well. All right, with that, I'm going to jump back into our slides. Kind of what we've gone through here today is looking at starting from an empty project, generating corridors, unit mixes, and apartments. The corridor and unit mix is included in basic. Everything with the apartments and on is included in enterprise. So let me jump back to our slides. So prior to us jumping into the poll or into the Q&A, it would be great if you guys can answer a poll just for us to get a sense of kind of the projects you guys are working on, features you want, where you guys are located, this sort of thing. So I'll just launch this right here in Zoom. And yeah, we really appreciate it if you can just let us know a bit about what you guys are working with. Right, I think you should see that popping up now. And just to reiterate, so we have a few different tiers here, free, basic, and enterprise. Free includes the massing tools. Basic includes the corridor as well as the unit mix tools. And that also includes a 14-day trial. And then enterprise includes the entire AI suite. If you do want access to enterprise for your firm, feel free to reach out to us and we can discuss getting you guys in. And a bit coming 2026, as Jesper went over, Nano Banana Pro and Finch, as well as the ArchiCAD plugin and the 3D Mass Editor. With that, we'll go ahead and jump into our Q&A, and I think Philip will help me out here with that as well. I'll stop sharing.
Yeah, so let's get going. So the first one is thanks for the demo and exciting feature. Would the Nano Banana integration vectorize furniture, etc., or just walls?
Yeah, great question. So we're actually looking into this right now. The first iteration of Nano Banana is focusing on vectorizing the walls and bringing those out. But when it comes to furniture, we are kind of thinking about a few different ways. I think what we are planning to do is kind of building a furniture generator optimization algorithm, where essentially then you could have the walls generated by Nano Banana and then tell Finch to, okay, create a few different options of furniture layouts for this office, and you're able to pick from those. We also are looking at extracting the furniture as vectors as well. But I think what we will kind of do is see how our existing customers are using it and kind of use their feedback to guide which direction that we head in. But I think that will for sure be an iteration too.
And then we have a question from Eric regarding if Finch is capable of generating multiple story buildings while also integrating landscape elements as part of the same design output. If this is currently supported or if there are recommended workflows.
Yeah, so Finch is mainly working on the inside of the building. Of course, our plans for 2026 to build the mass editor will allow us to kind of go outside of the building a bit more. But we do work on the inside of the building in a single story at a time, so we don't inherently support, multi-story apartments, if that's what you're referring to. But we do see a lot of architects starting out in Forma as they have a lot of good massing tools. You can run a lot of simulations and analysis there, and then of course bringing it into Finch after that.
Moving on, there's a question of if Finch is already trained or designed to handle layouts for retail stores and commercial spaces in general, as well as office environments.
Mhm. So the Finch generate plan feature is designed kind of with residential in mind in this data set. Of course, you can add any type of furniture, you can add any type of plan into Finch, but I think where we will really be seeing a lot of usage in retail, commercial offices is coming from the Nano Banana side of things, as Nano Banana has access to all of the plans on the internet as well. So it has so much to work from, and it essentially kind of is already trained on those type of environments. So that's where we're going to probably see that usage happening.
And moving on, there's a question, how does the generated unit plans relate to underground parking structure or structure in general, structure access, etc.? Can you connect it somehow?
Yeah, so we inherently don't generate parking, but we can consider structural elements such as like columns and parking spaces. The way that we see firms solving this is through the grid lines. I know that you can do like parking scripts from TestFit within Forma, and then you could send that over into Finch, and then of course use the grid lines to generate considering those structural elements. So that's a very common workflow for that.
And are we able to use Finch for more complex irregular parameters?
Yeah, absolutely. I'm thinking maybe I will actually just, I have a more complex project that I will demo usually if we have the time. So let's go ahead and jump in and take a look at that. Um, I think you can see my screen now. Go ahead and delete that. So yeah, here we have a more complex shape. This is an organic building. We support oblique angles, curves, kind of everything within that. What I want to do here is just instantly generate a really quick unit mix around this existing corridor to see what we kind of get out here. We have a lot of fine-tuned settings that we typically don't go over here in these webinars as they're a bit more in-depth, but you can basically control, will Finch align walls with the core or with the facade? Especially this is very relevant if you have like a non-perpendicular facade and you want the walls to come in at an angle on the core. You can also control like the resolution, these sort of things. But for now, let's just go ahead and say that we like this. We're happy with it. Now we're going to go ahead and generate a plan within. And you'll notice here something is looking a little bit different with the bounds than what we were working with before. And this is because Finch is able to take a complex shape and simplify it so that we can generate plans into it. So here we see that we actually have the bounds of the unit that contain this curve, but Finch is looking at this almost as if it's a much simpler shape. And this is why we build a really simple data set. So you'll notice in the data set that you didn't see too many curves, you didn't see too many crazy angles. And this is because Finch is able to take these rectilinear plans and complexify them into much more situations than the other way around. So the data set itself is kind of this foundation that then Finch is transforming into these more complex situations. We can see where the entrance door is here along this wall. It's kind of similar to how Revit works, where you're selecting that entire wall and you can, Finch can place a door anywhere along it. Then you also have the daylight apertures as well that you can turn on and off to control. Maybe you have a facade that has bad noise or a bad view and you don't want a bedroom generated there, then you could control and toggle those daylight parameters on and off. Let's say that we like this plan, gonna assign it out just like so, and then that's assigned into the unit just as before. But one feature that I really like when working with these types of organic plans, we see that because we have these grid lines on, we have two units that are the exact same width, but of course they have very, very different facade conditions. But that doesn't mean that the units themselves need to be very different. I mean, in this case, we could definitely share the core of this unit. So in this case, I just want to hit Control C, Control V, drop that in. We jump in this plan, we see that it's actually retained the structure of its neighbor. So we see we have an extra 10 square meters here. But if I just want to, keep this main plan, I'm just going to extend this out just a tad, like so. And then I'm going to union that. And now these are actually linked. So this is acting as a model group here in Finch. So if I adjust this kitchen unit and add it to this upper floor, jump out, that's actually committing to both of those units. So in this way, we have unique units, which is basically the shape of the unit. Of course, these are different shapes that we're working with here, but the content, the plans in the model group, this is the same and this is linked. And if I wanted to unlink them, I of course can make this unique and call this plan J. And then we add that in, and now these are unlinked. So any changes, are going to come in. They're going to come into Revit separately, and of course, they're no longer linked. So this is a really nice way to work with high rises that are very organic, and you can kind of control which ones are going to come in as model groups versus not. Same goes if you want to mirror plans. By default, they'll stay linked, but you can also have like a mirrored model group and an unmirrored one as well. All right, that's was about organic shapes. I think we can jump back to our Q&A here.
Yes. So Antonio is asking, how can Finch help in a project execution, and how can it help with project measurement documents for budgeting purposes?
Yeah, so I mean, when it comes to project execution, I mean, you get all of the data out, you're able to work through the project quite quickly. You can export everything as a CSV, you can get it down into Revit to make those custom schedules. And any type of calculation or number that you might want to get out, you can create in Finch. Because we are working with custom calculations, essentially you will input a coefficient for anything. So you can have budget, you can have carbon, and you can calculate that on the GFA, the NIA, these types of things. So you can get all of these areas and metrics out, and you can really understand the budget. You can even set up a budget parameter for specific spaces. So if you know that kitchens cost X amount per square meter, you can have those calculations updated in real time and be able to kind of compare different options.
Yes. And then about balconies, external and internal, how do we work with them?
Yeah, so internal balconies, we actually include in the floor plan. So we have a specific wall type that allows daylight to pass through. So then basically you can have, a balcony generating, but the bedroom is still reading that it's accessible to daylight. External balconies, we have a few workarounds for that. You can basically visualize them. Finch is not considering them in the generation. This is something that we are looking into for 2026. But right now we see firms kind of just using the grid lines, using maybe furniture to represent where the balconies are. So then when they're generating, they can kind of pick the results that have the rooms aligning to those external applications.
Yes, and moving on, are the firm's internal floor plans and furniture private? By private, I mean they won't be used by other users, nor for further training of your own models.
Yeah, so the client data sets are completely private. So any data you guys provide to us is not shared with anyone else. Only you and your colleagues can see it. And of course, in your own library, only you can see it. And we aren't using your data to train or anything like that. The only sort of data set that is public and accessible to everyone is that Finch data set that you guys can use.
And how does code compliance work in foreign countries? Does the tool have an internal knowledge base, or does the user need to manually add the constraints and codes?
Yeah, so it depends kind of on the studio that you're working in. I mean, when you're generating the corridors or when you're generating the unit mix, I mean, all of those parameters are set up by you and by you as the architect right when you're running it. So that's not pulling any information from a database because it's simply solving a puzzle with the input that you give it. When we look at the plans, then of course those are more code specific compliant. That's something that we take care of when we build up the data set. So we have some compliance written into the data set itself, but then we also have those additional graph rules that you as the architect can kind of put on top of the results you're getting. So you have this check coming from sort of both directions, partially from us with the data set and partially with you as the architect.
And the third one from the same person, are there any urban design or master planning capabilities somewhere in the pipeline?
Yeah, so I mean, we support master planning. We of course don't generate the buildings themselves, but we have seen a lot of firms. They will kind of upload a lot of different options that they're proposing for the master plan. Be able to get all of those numbers out. You can even kind of generate placeholder plans. You can get a really kind of credible amount or understanding of how many three beds can we fit in this entire development, this type of thing. So master planning is for sure a supported workflow.
Then there's a question on which models we can use for floor plan generation. I'm not quite sure.
If this is talking about the tiers, feel free to clarify if not. But with the tiers, floor plan generation is only included in the enterprise tier.
And can the floor plans also be provided or managed in 3D?
So Finch inherently is kind of working in 2D, but all of our assets are actually 3D. So, I mean, when you bring them into Revit, everything's coming in as 3D. You can even have 3D furniture as well. But the way that we represent the space planning in Finch is in a 2D view. We don't have like a 3D apartment view inside of Finch. But you, of course, can stream to Grasshopper and represent that there. And then you have the Revit as well.
And do you have plans to do housing estate residential development rather than apartments?
I wouldn't say this is something that we are looking into immediately now. I think, of course, with Nano Banana, this is something that it will be possible, and I think I'm interested to kind of test this out and see some case studies with it. It's not something we've tested yet, but I think when we look at like the generate plan algorithm, this is really optimizing a puzzle that has a lot of components in it, whereas single housing is a bit more of a smaller puzzle to solve. So I think there we're more looking at like the internal. And that will be something that I think we will see with Nano Banana.
Moving a bit into Revit, is it possible to import the families you use in Revit, organized under OmniClass, into the virtual model?
So everything that's in Finch is the kind of the Finch generic geometry, but you can save your import profiles when bringing stuff into Revit, so it will just automatically come in your families that you guys use.
And if I don't use Revit, is it possible to use Finch with Forma alone?
Um, I mean, you definitely can upload a mass and you can start and get to a point where you can generate through an entire project, but you will need kind of an export software in order to get what you've created out of Finch. So whether that is coming through Grasshopper or Rhino or Revit, those are the three ways we have out. We don't currently have like an IFC export or something like that, but you for sure can upload a mass, get into Finch and work through a project, but it might just live in Finch then if you can't get it out to Revit.
A little bit about the future. What features, tools are expected to launch in the near future?
Hmm? Yeah, so the sort of main things that we are launching soon is ArchiCAD plugin, which is coming here at the end of January. Nano Banana, we're starting to roll out as well to existing customers. And then, as Jesper mentioned, we are looking into building a 3D mass editor here in 2026. The first version of that will probably be editing existing masses up in Finch. So, if you're generating a floor plate, being able to just say, okay, what happens if I push out this facade a little bit and stay in Finch for that? And then eventually perhaps creating the mass from scratch in Finch as well. Additionally, we are also looking at like more graph rules, these types of things, but I would say those three are the big 2026 initiatives.
A little bit about the key figures. Can you include the balconies in the gross area?
Yeah, so this just depends on how you set up your project. I mean, you can include balconies in the mass and then you can mark them as balconies, and then you can control for every space that you create, you can control if it's included in GFA, GIA, NIA, UFA, all of that. So you have that control for sure.
And then we have one that says, is it possible to define explicit room constraints during layout generation, such as fixed door offsets from walls and minimum window opening requirements for living spaces?
So right now, this is something that we control in the data set itself. So like with those constraints, basically in the source plan, if you have like a standard, 200 millimeter offset door to wall, that will always be respected because Finch will kind of lock that distance between door and wall. And same goes if you have like the minimum constraints added on a bedroom or the fixed constraint on a corridor. So that is controlled in the data set. We are looking at perhaps bringing those as graph rules as well. So you could create like this space needs to be this wide, which could allow you to kind of use maybe more of the Finch results that don't have the constraints in them. So this is something we're looking at. But right now it's taken care of through your client data set.
And Amelia, from your experience, what project scale and typology does Finch perform best on? For example, where do you see the strongest ROI for a firm like ours working on large mixed-use and multi-unit residential projects?
Yeah, I mean, of course, the sort of more, the larger the project is, like high-rise residential is a really good use case because then you can really optimize repetition and kind of solving that problem. Also, if you have a very large footprint, it can be a nice way to kind of solve for maximum yield and make sure that you're not leaving like any residential area on the table, especially looking at like double-loaded corridors with egress distance requirements, these types of things. But I mean, we've been a residential tool for the past 5 years, so I think that currently the strongest ROI we're seeing is in these multifamily resi projects. We're starting to head into Nano Banana, but it's still so early that we're kind of still learning and understanding what will be kind of the strongest typology within that with our current customers.
Yeah. If there are only a few firms using the platform and whoop, now that got sorry. If there are only a few firms using the platform in a specific country, does this mean an office would need to train the system almost from scratch regarding local requirements and guidelines?
So if there's only a few firms from a country, this might mean that that country could be somewhat underrepresented in terms of the Finch data set. As the Finch data set is, it has a lot of Swiss plans as they have a lot of open source data. We have a lot of American firms, Australian firms, UK firms. So there's a lot of, that's kind of the focus there. But for every firm that we partner with, we build a custom data set. So I would say that even if you are the first firm from a specific country, that doesn't mean that your results will be any different than a firm from like the UK where we have a lot, because for every firm, we are building this custom data set. So it's that process.
Yes, and additionally, while the tool appears efficient, how does it address architectural design quality and deeper design thinking? For example, in the demo, identical apartments were replicated without considering actual orientations, resulting in a living room with no window or very limited one.
Yeah. So I mean, when we're replicating copying out projects or plans, Finch is aware of like daylight access. It's aware of what circulation is. So it is kind of auto rotating things like that. But I mean, all of the graph rules and checks are happening while generating. So if you do kind of mass populate out, I mean, you could have a case where like a living room misses the daylight, but then if you just turn on your graph rules, you'll get an error for that. So it's kind of just about using your spell check to make sure, because of course, all of the kind of analysis and rule checking is happening while you're generating a specific plan into a specific unit. And then once you spread it out, then you just have to make sure to turn on your graph rules. So I think that's a human error on my part.
And then we actually have a question regarding the workflows Finch to Rhino or Grasshopper, where we can get more knowledge about that.
Yeah, so in our Finch docs, which you can access directly through the web app, I can also post a link here in the chat. There we have tutorials about how to work through Grasshopper, how to work with Rhino. There's a lot of resources up there, so feel free to have a look. I'll just drop the link here in the chat real quick. All right.
Yes, and then we move on. What is the process for training Finch to populate a floor plan based on specific user requirements and constraints?
Yeah, so I mean, this has to do a lot with the data sets. So once you kind of have the user requirements from the data set itself, those will just automatically be generated through. This is kind of the idea of having that custom data set so that everything kind of already comes out in your style.
And will the recording be shared? And would you be doing something like 3D design to BOQ generation?
Yeah, recording will be sent out tomorrow. Can you clarify what BOQ generation is? And I can try to answer that for you. Uh, We see last question here that we maybe have time for, as it's almost 5. Finch's long-term objective, like the main goal and vision. I mean, right now we are really trying to create a platform that people can use to speed up their design process and trying to give them the tools that they can have complete control over what's generated. So that's why we have a lot of focus on the editing tools. We're also looking into more exports, things like that. But essentially, we want Finch to be able to save time in the process and also allow you to have more design freedom ultimately. So this is kind of the main goal. But of course, how that manifests is something that we talk to our existing partners about a lot. For example, we kind of developed the entire Forma plugin based on feedback. I mean, originally we were a Rhino only, started as a Grasshopper plugin. So we're kind of developing alongside our partners and understanding their workflows and how they want Finch to fit into that. All right, I think that's all we have time for today. Thank you all for joining. Really nice with all of the questions. As mentioned, we'll send out the recording probably tomorrow. Stay tuned for that. And if you guys are interested in getting access to Finch Enterprise, feel free to reach out and we can see if we can fit you guys in. All right, thank you all. Have a good rest of your day and see you in the next one. Bye.